Number 64. A sample of 0.53 grams of carbon dioxide was obtained by heating 1.31 grams of calcium carbonate. What is the percent yield for this reaction? Okay, so two things here. The first thing, as you guys probably know what I'm going to do if you guys have been with me throughout this whole journey, is I'm going to just rewrite this bigger. So we have, and maybe I'll put this up top here. So we have CaCO3. Just makes it easier for me to work with things. Okay, so we have calcium carbonate, which will decompose and break into calcium oxide, and CO2. But honestly, guys, who cares about the states? Goodbye. No one cares. Right? No one cares whether it's a solid or a liquid. It's just there to kind of like confuse you. Okay. The first thing I see is I don't see any coefficients, right? Or like any numbers. So I'm just going to do a quick check just to see if this is a balanced equation. But it looks like it is to me, okay? So, coincidentally, they're all ones here, which kind of makes it easier for us. Now, what I'm going to do is I'm just going to write down what the information they told us. Now, we heated 1.31 grams of calcium carbonate. That's this guy. So I have 1.31 grams of the calcium carbonate. And now they told us that a 0.53 gram sample was obtained, right? This was literally, if you were doing an experiment, you actually obtained this. And they're asking us for the percent yield. So the formula for percent yield is always this. So this we're going to have to use at some point, okay? Now, percent yield is just actual yield divided by theoretical yield. The actual yield is what you do in an experiment. And that's what they told you here. Chances are they're going to tell you the actual yield, okay? So a sample was actually obtained, 0.53 grams of carbon dioxide. So that's this number of CO2. If we want to find the percent yield and we know the actual yield, this is standard. The only thing we have to find is the theoretical yield. And it has to be the same units, right? So it has to be in grams of carbon dioxide. So I need to know what this is. Oh, I can get there. And what a theoretical yield is just what the answer should be in a perfect world, which we do not live in, okay? So if everything went 100% correctly, how much carbon dioxide should we have made? Well, that's this little stoichiometry thing here, right, guys? We've done this time and time again. So I'm just going to cater it to what we have, right? We have grams of CaCO3, which we can get the moles of, right? CaCO3. And then we can get the moles of who we need, CO2, and then from there we can find the grams of CO2, and we're starting with 1.31 grams. Okay, so let's get to it. 1.31, and then maybe I'll color code this. This is grams of CaCO3. Make your ratio because that's all that this is, right? Grams of CaCO3 on the bottom, mole of CaCO3 up on the top. Remember, if you're doing a mole to gram conversion of the same compound, you're using the periodic table. And the periodic table always says for every 1 mole, you add up the masses and you put that number down for the grams. So I have 1 calcium, so it's 40.08, plus 1 carbon, and then plus 3 oxygens, and each oxygen weighs 16. So I get 100.09. Units cancel out, and now we go to the next one. Multiply by a ratio, right? Mole of CaCO3 go on the bottom. I don't want that anymore, right? And you could always just look over to see, what you're going to next. We're going to moles of CO2. A mole-to-mole ratio of different compounds is always the balanced equation. That's why it's really important to know what the coefficients are and just make sure that they're balanced. But in this case, just like we said before, it's all 1 mole. So for every CO2, 1, because that was the coefficient, right? I need 1 calcium carbonate. That cancels out, and now we just got to go to the grams. This is the theoretical yield. So that's why we got to get there. This guy. So, multiply, put the moles of CO2 on the bottom, and put the grams of CO2 up on top. 1 mole, because this is the periodic table again. And maybe I'll just put this as the balanced equation. So 1 mole of CO2, go on that periodic table and get the mass. You have 1 carbon, so 12.01 plus 2 times 16. You get 44.01. Cancel out the units. And now we're going to find out the theoretical yield. So I'm just going to do this calculation. 1.31 divided by 100.09 times 44.01. And, I mean, we could cut it off to maybe 4 sig figs, because technically this isn't the answer yet. So 0.576 grams of CO2. This is your theoretical yield. So now all we have to do is, we know this number now. We know that the grams of CO2 is going to be 0.576. So maybe if I can, I will throw all of this a little bit down. Oop, what happened there? There we go. And now I'm just going to write over here, percent yield equals the actual yield. That's what they told us, 0.53, divided by what we should have gotten in a perfect world, 0.576, and then times by 100. Okay, this person wasn't so far off, right? They got 0.53 grams, could have gotten 0.57, so probably going to be a good yield here. So 0.53 divided by 0.576 times 100. Yeah, looks good to me. 92.2 sig figs, technically. So 92%. And we could think about a percent yield of like a grade on an exam, right? The best percentage we could have gotten was 100%. That means that there was no error. But, you know, there's always going to be error, you know, doing experiments. Nothing we can do about that. So, I mean, 92% is really good percent yield. So kudos to this person. All right, guys. Hopefully this helped. Let me know in the comments. Thank you so much for viewing the video. And let's keep studying hard, okay? Have a great day. And I'll talk to you later. Okay, bye-bye.